All right, 2.1, use integers and rational numbers. So some of this may still be familiar to you from pre-algebra, and some of it might be new as we move in now to chapter 2. So a couple things, some definitions. Whole numbers are the numbers like 0, 1, 2, 3, and so on and so forth. Okay, if I do dot, 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 that just means it keeps going in whatever direction the dots are. Integers are negative numbers like -2, -1, 0, 1, 2, and so on. So all negative and positive numbers as well as 0 are integers. Obviously, positive numbers are like 1, 2, 3, so on and so forth. Negative, -1, -2, -3, so on and so forth. 0 is not positive or negative. A lot of times people try to classify 0 as like one or the other, and it's not either of them. So there may be questions that ask us to like plot points on a number line. And so basically we'll draw out a number line and then we'll just put the numbers on there, and then they'll want to know which one is greater, things like that. We also have rational numbers, which are a number a over b such that a and b are integers and b is not equal to 0, because if 0 is on the bottom, it is undefined. So an example of that would be like 3/4 is a rational number. So we can have, it kind of like works its way up. So whole numbers are all also part of the integers. So I'm going to draw a little table here so you can see how this all comes together. So I start with whole numbers. Then I have integers. And whole numbers are part of the integers. Then those things are both part of rational numbers. And then ultimately all of these things are real numbers. And you might be thinking, why is she calling them real numbers? Because we also have imaginary numbers that you'll learn about later on in math. Yes.
So, do whole numbers include negative numbers?
No. Whole numbers are counting numbers. Some people say that 0 is not a whole number either, but our book says that it is, and I usually classify it as one. But it just depends on the book.
So, when it says whole numbers are counting numbers, does that mean they're numbers you can count, right?
Yes, like
So-
1, 2, 3, 4.
Well, you can count with like decimals, like 1 point something like that, but that count is 2.
Right, but this has whole numbers,
Okay.
which implies the whole thing. Yes.
So when you mean counting numbers, do you mean like say like 0's like 100? Like if you had a camera 0
I
to
mean,
100.
all the way up to like 5 million. I mean, like it just keeps going. Those are all counting numbers. Now, obviously, we wouldn't want to count one by one to get there. That would take forever. But anything like that, that's essentially positive integers are all whole numbers plus 0. Now, to get to what you are asking, decimals. It's another type of number. And decimals are also real numbers. Decimals can also be rational numbers. And decimals are rational numbers that terminate or repeat. So to go back to 3/4 that I had earlier, 3/4 as a decimal is what?
0.75.
0.75. That terminates, right? It has a stopping point. It's 0.75 and then that's it. However, if I had something like 1/3, anybody know what that is as a decimal?
0.3 in front of like.
Yep, 0.3 repeating. We usually put the line over it for repeating, and so that is a repeating decimal. Now, sometimes you'll have a decimal that ends up giving you something like 0.345345 and so on and so forth, and that would also be obviously a repeating decimal. But if at any point it stops, okay, so even if you have something like 0.2345 and then that's where it stops, that's terminating. So some questions may also ask us to classify a number, and we would want to classify it in, obviously as specifically as possible. What else? Absolute value. Absolute value indicates a distance from 0. So any answer that is in an absolute value is going to come out to be positive. Okay? So absolute value always produces a positive number. So some examples of this for you. If A is positive, then the absolute value of A, so absolute value bars are like the two long bars, they kind of look like giant ones, is equal to A. So with numbers, if I have the absolute value of 5, that's equal to 5. If A is 0, then the absolute value of A is equal to 0. So if the absolute value of 0 is equal to 0. Then if A is negative, then the absolute value of A is equal to negative a. Now that's written kind of weird, so I'm going to show you what it is with numbers because the way it's written is weird. So if we have the absolute value of negative 3, okay, but a is negative, what that's telling us is that my final answer is negative times the negative number that it was, which ends up being positive. So it's kind of weird how it's written, but.
So basically, if it's a negative number inside of it, then it's just gonna end up as a positive.
Yep. Your result, anytime you have the absolute value of anything, should be positive, with the exception of if the absolute value is 0, then obviously it's going to be 0. Yes.
What if the negative's on the outside of the bars?
Then it would be negative.
Alright.
Is that your question too?
Yeah.
Yeah, good. Yeah, I'll put that up here too. If you had something like, negative absolute value of a, then this would be equal to negative a. So in numbers like negative absolute value of negative 4, then that would be negative 4 as your result, because the absolute value of this would be a positive 4. I don't know for sure if that's in this section, but not a bad thing to go ahead and talk about it. The other thing here in this section that we have are called conditional statements. And these have a hypothesis and a conclusion. Another name for them is an if-then statement. Have y'all seen these before in science class? No, not yet. I think it more comes up in like physical science. That's why I wasn't sure. You'll also see them in geometry next year a lot. We don't do a ton with them in algebra, but it's good to get familiar with them. So all of these statements that I wrote up here in purple are conditional statements. If A is positive, then the absolute value of A is equal to A. Those are all conditional statements. So I'm going to rewrite one of these down here so that we can look at it. If A is a positive number, then absolute value of A equals A. So this whole thing is called a conditional statement. This first if part here, if A is a positive number, is our hypothesis. Then the then part down here is the conclusion. Now, when you're given these statements, they are either going to be true or false. So an example of this, I could say, let's see, if a number is a rational number, then the number is positive. So what is my hypothesis part?
If a number is a rational number.
Yep, so this part right here, this whole statement piece, is the hypothesis. What is the conclusion? This whole piece. This is the conclusion. Is this statement true or false?
False.
Why?
Because rational numbers can also be integers or negative numbers.
Yep.
Or decimals.
So this would be false because negative numbers can also be rational. Another question for you. What is bigger, a positive number or a negative number? Positive number. What's bigger, negative 5 or negative 1?
Negative 1.
Negative 1. Good. All right. That means we're ready to move into some examples from your homework. All right. The first one say to graph the number on a number line and tell which number is greater. Okay, which is essentially what I was just asking you questions about. So number 6, the number 0 and negative 4. So I'm going to do a little number line here. And you only need to really put, like, you know, I don't need you to go all the way out to positive 4 considering my biggest number is 0, right? So I'm not, like, super picky about that. Don't just put, like, 2 numbers on there and that's it. Like, put a few on the number line. If you need to count by 2s because it's, like, really big in either direction, then that's fine also. Yes.
Can I still count by 2s even if it's that small? Because I did.
As long as you have it labeled, then that's fine. All right, so I plot the points on here. We just put a little dot where they are. So at 0 and at negative 4. And then which one is greater? 0. Ten. Negative 12 and 8. So on this one, I would recommend counting by 2s just because it's kind of big. You're going to end up with a really big graph.
Could you do it by 4s?
Kind of.
Yes, that's fine. But you have to do the whole thing, like the same thing. I didn't make this big enough. All the way down. Don't just do like 4 on one side and like 2 on the other side. I cannot write. Okay. There we go. So yeah, counting by 2 is a little bit big still, but so we plot negative 12, we plot 8. So which is bigger?
8.
8. Let's see. Are we okay on that?
Yes.
Do we feel like we don't need to see any more examples of that? Okay. Sometimes I won't do as many and I'm just going to ask, and if y'all need to see more, just tell me, and if you're like, now we're good, then we'll just keep going. Okay, classifying and ordering numbers. Tell whether each number in the list is a whole number, integer, or rational number, then order the numbers from least to greatest. If you want to use a number line to do it, that's fine. If you want to just write them out, that's also fine. I don't care which method you use. So 14. We have the numbers 3, -5, -2.4, and 1. So first of all, I need to classify them. So what is 3?
Whole number.
What else?
It's a real number. It's an integer.
So they're, just so we know, they're not doing real. They're just doing whole, rational, integer, and I guess, yeah, that's it. Oh yeah, there's the list. So whole, integer, rational. So what all is this one?
Whole integer and rational.
Yep, this is all 3. If y'all want, since these all start with something different, if you want to say like W, I, and R, like, and to abbreviate them so you don't have to write the whole thing out, that's fine. All right, what about -5? What is it?
Integer.
Is it anything else?
It's rational.
Yep. But it's not whole because it is negative. How about -2.4?
Just rational.
Yep, just rational. And 1?
All of them.
Yep, whole, integer, and rational. So now I need to put these in numerical order. What order do they go in?
It'd be -5, -2.4, 1, and 3.
I knew that.
You have a question? Sam? You just raising your hand or you have a question?
Just stretching.
Okay.
Yeah.
I have my glasses on, so I keep like seeing things like it's just like the frame of my glasses, but I keep thinking people have their hands raised, and I have to like keep looking and being like, nope, it's not. This one will be interesting. 18. -0.01, 0.1, 0, and -1/10.
Would 0 just be another?
Do what?
Would 0 just be
Well, 0 is a whole number and an integer.
um,
All right, let's classify first. What's -0.01? Rational. What about 0.1? Rational. What about 0?
All 3.
Yep. Yep, it's all 3. Whole number, integer, and rational. And -1/10.
That'd be just rational.
Just rational. All right, now I need to classify these. Now, are they all in the same form? No. I like to go ahead and write everything in the same form so that I don't get confused. So since basically most of it is like a decimal, I would rewrite your fraction as a decimal. What is this fraction as a decimal? Negative what?
-0.1.
Yep, -0.1. So I need to order these in order from, what are we doing? Smallest to largest. So what would that be?
-0.1, -0.1, 0.1.
Hold on, say it one more time.
negative 0.01, negative 1/10, 0, and then 0.1.
Magic. Drink's not coming.
Okay. I was looking at something because the book has them out of order, and I was trying to make sure that we had that right. But yes, this is correct. Book has a typo. All right, let's do one more of these ones. 22, negative 3/5, negative 0.4, negative 1, and negative 0.5. All right, classifying negative 3/5. What is it?
Rational.
Rational, negative 0.4. Rational, negative 1.
Rational.
And integer and rational. And negative 0.5.
Rational.
Yep. All right, now I'm going smallest to largest, okay? I don't have, obviously, negative 3/5 is not a decimal, so I should probably try to make it that. Anybody know what it is?
I have it ordered, but last time I tried to explain it.
Huh?
I have the order.
Yep, negative 0.6. I like to do everything out of, like, to get it out of, like, 10, so I just multiplied top and bottom by 2, so it was negative 6/10, which would be negative 0.6. So, what's my order smallest to largest?
Negative 1, negative 0.6, negative 0.5, negative 0.4.
Yep. And if you wrote this negative 0.6 as negative 3/5 instead in your lineup, or you left it as the decimal, I don't care either way since it's the same thing. So,
What if you forget to say that negative 3/5 is 0.6? Which
and you, as long as you have them in the right order, that's fine. Technically, the book is going to use the form that they gave it to you originally, and so if you're checking your answers, it's going to be in its original form, but I'll take it either way. All right, any questions on those ones? Okay. The next thing is finding opposites and absolute values. So we didn't really talk directly about opposite, but if I said 3, what is its opposite?
Negative 3.
Negative 3. If I said negative 4, you're telling me its opposite is? 4. Okay, so we didn't really talk about that, but I figured y'all knew what that meant. So these say for the given value of A, so it's going to say A equals some number, find negative A and the absolute value of A. So I'm going to write that here. Find negative A and the absolute value of A. So 24, they give us A equals negative 3. So what is negative A?
That'd be negative 3. Wait, I didn't.
Positive 3.
So basically, the negative A is just tell me the opposite of whatever they gave you. So positive 3. What is the absolute value of negative 3? 3. Which that was the absolute value of A. There. Here's an interesting one. 26. A equals 0. What's negative A? 0. 0. What is the absolute value of 0? 0. Good. I thought I was going to trick somebody. One time somebody told me the answer was -0. And that's why I said earlier, like I made such a big deal about the fact that 0 can't be negative or positive but I still thought I was going to trick somebody, so good job.
Negative.
32. A equals -5/6. What is negative A? 5/6. What's the absolute value of -5/6? 5/6. We okay on those ones? Any questions about that? So the first thing is find the opposite. Second is find the absolute value. All right. Identify the hypothesis and conclusion of the conditional statement. Tell whether the statement is true or false. We're not going to do the false if it's false part. All right, 36. If a number is negative, then its absolute value is negative. All right, what's the hypothesis part?
If a number is negative.
Yep, if a number is negative is the hypothesis. If you just want to like shorten it to like HYP or something like that, that's fine. What's the conclusion?
It is
Then its absolute value is negative.
Yep. Conclusion. If you just want to say like H and C for hypothesis and conclusion, that's fine. Also, to shorten it. Is this true or false?
False.
Why?
Because
Absolute value can't be negative.
Yep, absolute value can't be negative. When it says if it's false, give a counterexample. Essentially, it's just saying to like show what it would be if it was correct. So, but don't worry about that part of it. 38. If a number is an integer, then the number is a rational number. What's the hypothesis part?
If a number is an integer.
If a number is an integer, so if you just want to put like an H over it, underline it, something like that is fine. But don't just underline and not put anything else because that doesn't tell me that you know what you're doing. And then what's the conclusion part?
Then the number is rational.
Yep. So that is the conclusion. Is this true or false?
True.
It's true. All right, any questions on any of this stuff?
Nope.
I know some of it's a little like tedious, kind of annoying, but I promise it will help you later on. All right, today's Wednesday, so remember no homework, but you have 15 minutes that you should be working on this stuff. Let's see. After you write down these homework problems. 9, 11, 15, 21, 23, 29, 33, 35, 37, and 39. Yes.
All in favor?